Hello everyone, welcome to another video of BIOSTAR Health, our knowledge sharing platform. Today's topic is on different types of data and how data is classified based on the scale or level of its measurements. Let's look into this table. This table comprises of 7 columns, each representing different variables, and 14 rows, each giving specific observations or measured values from 14 cases or samples. If you look closely through the table values, we can see that some of the columns have characters written like male, female, stage 1, stage 2, stage 3, and other columns are filled with numerical values like 2, 36.4, 15.2. Even though we consider all of them as data, there exist different types of within them. As a researcher, we should be able to identify those specific category of our research variable. This is because there are different methods for displaying the data like chi-square test, t-test, pair t-test, regression, etc. So it is a type of the data and its scale or level of measurement decides which method we have to choose for conducting, displaying and analyzing the data. Therefore, it is very important for us to understand. So, our entire task is to understand what are the types and what are the different levels of measurement. Broadly, there exist two types of data. One is qualitative data, which places the individuals into categories that do not have numerical values. Two, quantitative data that have numerical values. The qualitative data are considered as categorical, and there exist two different levels or scales within them, that is nominal or ordinal, which we will discuss later. Quantitative or numerical data are considered into or subdivided into discrete data, where the measured data can take only or assume fixed number or counts. Like, for example, number of children, number of visits to doctor, where responses limits to specific numbers like 0, 1, 2, 3, etc. They can take only a limited number of discrete values, which are usually whole numbers. The variable number of brothers or number of sisters takes integral values only, in which that is why there won't be any 2.6 or 4.5. That is why they are called discrete data, or in a way it can be considered as a count data also. Then the quantitative data is subdivided again into continuous data, where it can take on any real value like height, weight, age, temperature, etc. Continuous variables theoretically can assume an infinite number of values between any two fixed points. Again, as I mentioned above, qualitative and quantitative variables are categorized further in relation to the scale or level of its measurement. They are called nominal, ordinal, interval and ratio scales. Further, we look into each of this and the characteristics of each of these levels or scales of measurements. Nominal measurement scale is the lowest scale. As the name implies, it consists of naming the observation or classifying the categories. We may come across collecting the information for gender, where there are two options, either male or female, or sometimes we may ask the response for blood group. So there could be either A, B, AB or O. There is no quantitative relationship between the categories, and the categories are mutually exclusive also. Hence, it is called as the lowest measurement scale. This type of nominal measurements are usually described in the form or presented in the form of a bar chart or a pie chart. To summarize, you can use either proportions or percentages. For example, the percentage of males in your entire population, percentage of females in your entire population, percentage of persons having A group blood, percentage of person having AB group blood. So this is about nominal measurement scale. Coming to the next is the ordinal measurement scale. We may come across variables like stage of cancer. It could be stage 1, stage 2, stage 3 or stage 4. When you look into the data responses very closely, we can see that the data values will give an inherent order in that, or it can be ranked like we know that stage 3 or the stage 4 is having a poor prognosis when compared to a subject having stage 1 or stage 2. That means it is not only the observation can be categorized like the nominal, but there is an additional characteristic as there is an inherent order, or it could be ranked also. So this is one step ahead than the nominal measurement scheme, which is called as the ordinal measurement scale. So therefore, whenever observations are not only different from category to category, but also can be ranked, they are said to be measured on an ordinal scale. But it is also said that even though you can order, but the difference between any 2 points in an ordinal scale will not give any mathematical conclusions. Even though we can say that stage 1 is less severe than and inherently lower rank than stage 4, but we cannot make any quantitative measure. That's why again ordinal measurements are qualitative measures. And finally, you can present the ordinal measurement scale in a bar chart and summarize using proportions or percentages. Next is coming to the interval measurement scale. Here it is one scale ahead of ordinal scale where more functionalities when you look into the data. As I told, this is a type of quantitative data or numerical data where numerical values can be collected. It is a continuous data where data can be collected in numerical values. If I collect value of temperature on a Celsius scale or a Fahrenheit scale, we can see that we may get values with respect to 37.5, 20, 25, 10 degrees Celsius, etc. Here the measured values can be ordered or ranked. We can calculate the precise difference between the values, but there are some disadvantages of interval measurement scale. When you compare with what is the next level or the ratio scale, the interval measurement scale, even though we can calculate the exact differences between 2 points, that is from 10 degrees Celsius to 20 degrees Celsius or from 30 degrees Celsius to 40 degrees Celsius, but there is no meaningful absolute zero. That means 0 degrees Celsius doesn't mean that it is a total absence of any temperature. This is because of the fact that Celsius is graded from a positive points to the negative points, where you have positive values with a high temperature and negative values on the lower temperature and 0 in the middle. Therefore, 0 degrees Celsius doesn't mean that there is an absence of any temperature. So it is no meaningful absolute zero. And also we know that from 20 degree to 10 degree change in temperature will not be 40 degree to 30 degree, even though mathematically the difference is just 10 degree, but temperature wise you won't get that. The quantum of temperature will be different in both the situation. This is what is a characteristics, even though it is considered above nominal, ordinal scales. And that is why we have a final scale which is called as the ratio measurement scale, where the measured variable values can be ordered or ranked. There is precise difference between the units of measured values. There is also meaningful absolute zero. We can calculate a ratio of the two variables. Just for example, if we look into the height, we know that 0 millimeter means there is absolutely no height. 0 pound means no weight, and we can calculate 60 pound upon 30 pound means it is 2:1. Therefore, we can calculate the ratio also. So this is the highest level of measurement scale. Usually, but not always, in biomedical researches, ratio measurement scale and interval measurement scale are considered together. So it is for those whom are engaged in doing researches, it is not a must to understand the difference. But for academic purposes, we need to know that there is a ratio measurement scale and interval measurement scale and its differences. Coming to the application of this entire classification is that different scales have different types of presentation. Data scales and level decide specific types of tabular presentation, specific types of display, specific types of summary, and specific test. And this is an example of all these things. How you display all these nominals, ordinals is used. Usually we are presenting it by contingency table and displayed through bar charts, and summary is taken through percentages for nominal, and we have mode representation for summary in ordinal. And usually nominal scales we go for testing the difference between two nominal variables using the chi-square test, and for ordinals we depend upon Wilcoxon sign rank test or Mann-Whitney U test, which we will discuss later in other episodes. Test for interval and ratio we use Z test or student's t test, etc. There are multiple display graphs like histograms, box and whisker plots, frequency polygons, stem and leaf displays, etc. And most commonly, to summarize the data, mean and standard deviation are used, but depending upon the distribution of the interval and the ratio parameters, we may have to go for median or mode values. So that is the end of this. So finally, what we learned from this entire process is that when you look into the first table, we had gender is usually can be considered as a nominal scale since it has got two categories or categories only without any order. And stage of cancer, since it is stage 1, stage 2, stage 3, it can be considered as a ordinal. Number of children variable, it can be considered a discrete, numerical value without any decimals. And degree temperature can be interval scale, and weight in pounds can be considered as a ratio scale. So this is the entire process of presentation. Thank you for watching this, and if you have any specific comments, please put on our comment box. And good day from BIOSTAR Health.